You're listening to The Modern Mainframe, BMC's intelligent Z optimization and transformation podcast, covering the latest trends and issues on the mainframe and how BMC AIME and BMC Compuware Solutions can help you build a mainframe-inclusive DevOps toolchain. Hello there. Welcome to The Modern Mainframe. I'm Matt Delaire. Our subject today is mainframe testing, particularly a new e-book titled 10 Steps to Effective Mainframe Testing. The topic is an important one. The lack of effective and efficient testing of mainframe code not only adversely affects the quality of software, it slows down the development process, which is a big problem in today's fast-paced digital economy. Recently, Forrester Consulting produced a total economic impact framework on mainframe testing, interviewing 5 global banks and insurance companies about their usage of automated testing for mainframe applications. The results were quite compelling. The report, and I'll include a link in the show notes, found that organizations that were spending 2 to 3 days manually testing were shortening that time to 2 to 3 hours with automated testing. Overall, organizations employing automated testing saved 90% in testing time, 10% in developer time, and 20% fewer bugs in mainframe code. 10 Steps to Effective Mainframe Testing proposes a path to faster, more accurate testing of mainframe code and a better development outcomes while answering questions like, how can you know whether or not you have tested the relevant pieces of mainframe code? How should you measure testing? Is automated testing optional? What are the risks of testing mainframe code manually? And more. So joining me today are the eBook's authors, BMC DevOps Evangelist Tony Anter, and Senior Product Managers Paul Allard, Kevin Corbett, and Mark Schettenhelm. So everyone, thanks for being here. Thanks for joining us.
Thank you. Pleasure.
So the first step listed in the ebook is determine your current desired state. Tony, why is that the first step?
Glad you asked, Matt. This is going to come off probably sounding a little bit like a cat poster, but if you don't know where you're at, you're never going to understand where you're going. If you can't understand the current state of your testing, the current state of what you're doing and how you're doing it, then how are you going to be able to plot out where you ultimately want to be? And how are you going to be able to understand the steps necessary to get there and measure against where you were?
In what ways can organizations set that baseline or find out where they are now?
I think it's just taking a good, hard look and self-assessment of what are you doing today? How long is it taking you to currently do your testing? Is your testing automated or manual? Where does it fit in your process? And if you can't figure that out, you have guys like us, like myself, Mark, Kevin, Paul. We can help you assess that, right? I can come in and work with you on where are you at today? What are those chinks in the armor? And how can we fill those? What's the best way for you as an organization to get from the current state you're at to your desired state?
So step 2 is modernize your mainframe development environment. It suggests taking inventory of how you test and how you measure testing, as you mentioned, as well as the tools you have versus the tools that you need. Tony, is this just an assessment of your tooling, or is it more than that?
It's more than that, right? It is an assessment of your tooling, and that's a part of it. But like we said, when you're talking about DevOps in general, DevOps is not just a tooling conversation. It's people, process, and culture. You have to see what is not just your development tooling and how your environment is set up for your engineers and testers to be able to work, but you have to modernize your culture. You have to modernize your practice. And you specifically have to bring in tools and processes and capabilities so that you're automating all that where it can be automated. You're making your development process a delight. And I use that word because it comes from the Unicorn Project with Gene Kim. You need to make working in your development environments a delight. And to do that, you have to assess and inventory what you have from a testing point of view, what you have from a testing development point of view, and you need to now bring in all of the pieces necessary to make that a delight.
So we have these 10 steps listed in the book. Can you skip around on these steps? Are they meant to be taken in order?
They are meant to be in order. Each step builds on the previous step and sets up the foundation for the step after it. That you might be more mature in some areas than others. You might have already modernized your development environment. You might understand your desired state, but that means you've just done it in the past. You still have to have those pieces in place to build the scaffolding for the next piece.
I'm going to quote the book here. A surprising number of organizations do not understand all of their code or how it works, nor do they fully understand their data. End quote. And it goes on to mention how the data works, what data is called, how it's structured. Mark, I think you can speak to this in terms of code, and Kevin in terms of data. But how can it be that organizations don't understand their own codes and data? And what are the risks involved if they don't know these things?
Yeah, I mean, Kevin and I are going to kind of go back and forth on this one. There's so many programs in your portfolio, it's hard to really understand them. And you certainly have to understand how the code works to test it. And you also then need to understand what data is involved. And since I said data, Kevin will probably want to jump in on that.
I will, but I want to jump back to where you were too. Data is very complex, especially in today's environment where we've got companies acquiring other companies, and you try and assimilate all that information into your processing. And it's quite obvious that you can't possibly know what all of the inputs and outputs are into your application from the programming side, but also from the data side. You have to understand what that data is, and the knowledge just isn't there anymore. I mean, somebody may have it, but maybe they're on a different project. So it's, you've got to you have to have a tool that's going to tell you what are the inputs and outputs of not only this program, but this entire application.
Okay, and that turns towards me, Kevin. So as far as the tool, what we propose is we have a thing called the Runtime Visualizer, where you run your program and we can automatically chart it. You don't have to do anything to your program. You can submit it. I'm not getting all the technical details here, but while it's running, it will build a chart of it, and it will chart that every time it calls another program and going to data, every time it hits DB2, what table is it a read, is it an update, does it delete, IMS calls, and of course, VSAM files, file files. So you can all you have to do is run the program and it will tell you all the inputs, and you can gather then, okay, to do this test, I need these files, I need these tables, and know that within minutes. And I think that leads to you, Kevin, is then you have that data, right?
Exactly. That's the first step in understanding what data do I need and where do I get it from. The second part of that is probably covered in multiple steps in the book, but it's how do I know what data I need to do my testing? It's really a tough call, but that first step is understanding what are the different data sets that I need, or data, files, databases, whatever they are, so that I can start to understand how that data is related, and what it is I need to do my testing for whatever the project is we're working on.
And you guys don't know how many different people I talk to that this is a major issue. This is what is one of the biggest hurdles to preventing them from actually automating their testing, is this understanding.
Data is hard. Data is hard to understand, to know what the relationships are between them, because there is, the days of a single file coming into a COBOL program with a single output are gone. We've got very complex applications running on multiple platforms, multiple technologies, and it gets extremely difficult. Right. As a matter of fact, we've had many companies we work with, they have a whole group set up just to do this kind of data management on behalf of the applications teams. So they work with subject matter experts to understand what's needed, and then they gather the data, put it together, and move forward with it.
Right. And I think what the book is really saying is we understand this problem, like you said, Tony, that everyone faces. We understand it, but you shouldn't use that as an excuse or reason not to do everything else. This is not insurmountable. As I said, there's an easy way you can just run your program and determine what the inputs and outputs are. Programs you've never touched before, you run them, okay, here's all my inputs and outputs. And then you can you've narrowed it down to know what the data sources are, and then you can start doing more analysis with them, Kevin. So there's some techniques, and, that's beyond the scope of this podcast, but it's not insurmountable. Tools exist, techniques exist. You can get past this, but you need to understand this before you can advance.
Absolutely.
So is the test data compiled for each individual test?
No, I would say no. Maybe in a unit test scenario, you might do that. But as you get into more testing, what you want to really do is, once you've understood all those relationships and everything, you want to gather what I call a gold copy, and others do in the industry as well, of test data. And that could be from multiple data sources. That can be privatized, because we found that getting your data from production is really your best source, because it has all of the real world conditions in it. May not have every condition you're going to need, depending on what kind of enhancements you're making to your application, but it has the base to drive most of your testing. But you want to subset that into a smaller, more manageable set of data so that your tests run more quickly. We've had customers that don't want to struggle with figuring all this out, so they simply take a copy of their production data, regardless of how many data sources that is, and replicate that in their test and development environments. Well, one, that's a lot of space. Two, it's a lot of time. And when you try and run any kind of a test, whether that be unit or system or integration, performance, whatever, they take forever. So it certainly doesn't lend itself to DevOps, because you're not going quicker. It's slowing you down, and that hurts. So we suggest a very small subset of data. Again, you need to have a tool that can tell you, what is that data that I need? What are the conditions I need to meet in order to say that I've tested my programs and applications completely? So that's kind of a segue over to Mark, I think.
Right. And it really leads into code coverage, to really know what's been covered with the data that you're supplied. What you would do is you would take the input, as Kevin said, you might start off with something that is production data, but that doesn't mean you have to do production volume. You don't need millions of records to test a few lines of code. What you need to do is run it with code coverage, which is the real game changer here, I think, in the whole process. Without having code coverage, you don't know the effectiveness of your data. You could be testing small sections of the program and totally missing things. What code coverage does is show you exactly what you're hitting. You'll find, as I think Kevin alluded to, there might be conditions you're not testing. Even with production data, it will tell you that. And then you can do things like we've had customers take the data they were using, cut it in half, find out the coverage was the same, cut in half again, and just keep this process until they get down to very few records and find out that with a few hundred records, even less, they get the same coverage they would with the massive amounts of data. Without code coverage, you're testing blindly and you're guessing. And code coverage gives you that mastery over your testing.
Yeah, I see a lot of companies conflate stress and load testing with functional testing, and you're trying to accomplish different things. There are times when you're going to want to throw 1 million records at something, but that's stress testing. That's to see how your system operates under load or under stress. That is different than functional testing, where you're trying to test, to Mark's point, you're trying to test the change. You're trying to test a specific piece of code, a specific business operation. And for that, to Kevin's point, carrying all that data around, it's wasteful. So we have to get people to understand that you might feel more comfortable with that massive volume of data, but you're actually hurting yourself in the long run.
Right. And, there's a really good graphic, and unfortunately, this is audio, but there's a graphic in the ebook that shows it's two big triangles, and it shows that when you're doing your original unit testing, and I know Paul's probably wants to jump in on that, and we'll give him time to talk about unit testing. But when you're doing that test more often, you test it a lot more times, you need less data. Because I could use 10 records maybe and test that fine because I'm just testing the logic here. But that test, you might do it after every compile. On the other side, what Tony was talking about is stress testing, performance, or regression testing is done infrequently, but that might require more data. So it's an inverse relationship. The more often you test, you want less data, and the less frequently you test, you can use more data. Testing with less data means you can test quickly, cheaply, and more often.
And I'm actually looking at that graphic you mentioned now. It's on page 11. It's almost like a triangular Venn diagram.
Yeah, exactly.
I felt like Mark painted a picture with his words.
He did. He's good at that.
Yes.
So you mentioned code coverage. How can companies do that? How can they ensure that their code is covered?
Right. And it is, again, the key thing. It's not an evasive thing. It's not difficult. To work, you have to compile it so that we have the source code, which is what you do with Avendate or Expediter. Doesn't change your program in any way. It just stores off the listing so that we know the line that executed. And then you run the program with code coverage turned on. It's a product of ours. And what we do there, now that does take some overhead, but it will go through and record each line that was executed. And then you will have the results at the end of the run. So it's as simple as just submitting a job or doing it online after turning on code coverage. So there's no reason not to do it. And then you'll have that information. And I mentioned that it does take some overhead when you run it for your test. But once you have that information, you can use that to do the data subsetting that Kevin was talking about. You can start getting smaller test data. So it's a one-time investment that gets you something going forward with tests that you know will hit your code.
And Mark, I wanted to jump in. Mm-hmm. An optional byproduct of running this code coverage is you can actually optimize the data that's required for your testing using a test data optimization option that's available. And that'll tell you exactly the records that you used when you were doing that test. And those are the ones that you can subset and use to repeat that test time and time and time and time again.
Right. And that's a great message because, as we said, this is a thing that confronts everyone and it seems overwhelming. And we don't want people to toss up their hands and say, it can't be done. Code coverage, as I said, there's no excuse not to do it. You just run it. And the test data optimization, what it does is it looks as it's running through there. And when it hits a new path, then it says, oh, this is a new path. Record all the data that you currently have that got me to that path. Then it runs along, and then you're hitting those same paths hundreds, thousands of times. It just, okay, we get the code coverage, but it doesn't record any data. When you hit a new path, it does it. And so in the end, you have just the records needed to get to those paths. And you're going to find it's going to be shockingly small amounts of data, but they will thoroughly test your program. So it's a totally automated way to pull out the smallest amount of data to give you that coverage.
So, Mark, how can organizations ensure that testing covers lines of code that have actually been changed?
That's the core of it. And the book mentions it. Is for one thing, as I was just talking about coverage. So you might mention that you run a test and you get 40% coverage. You're never going to get 100% because there's things like error routines. It's a good way to find code that maybe isn't dead, but because your data, you're just not going to hit it. But the real critical thing is change lines of code. And what I always say is that all changes will be tested. The question is whether they're tested in-house during your testing process, or they're put out in production and your users test them. Either way, all your code will be tested. So what testing is to pull that in and make sure it's not your users doing your testing. And if you don't have a way to know what your changes are, you can ensure, like part of a quality gate, that 100% of my changes have been tested. So we discuss ways that you can go through and mark the code. One is just to tag it in line 73 through 80. Sometimes people say, well, developers won't do that. In Topaz, you can just turn on a little switch and it will go in and mark it automatically. So when you have change lines, it's done. And we also have a utility that can compare two versions and automatically mark it. So you can make it a standard. You could have that be part of the code review. But we also have tools that would help enforce that. And that's critical, because where it really comes down to is knowing whether your change lines have been tested. And if they aren't, you have real risk. And there's just simple ways to go mark your changes. And once you've got that in place, code coverage can use that so you can make sure before it goes into production, 100% of your change lines have been tested.
So Mark mentioned unit testing a moment ago. Paul, sometimes there's confusion over what unit testing is. Could you clarify that and explain its importance?
Sure. Basically, unit testing is taking the smaller part of a application and breaking that down and testing those components within that smaller area. For instance, at a very high level, let's take the example of a car engine. I can remove the spark plug and only test the spark plug and put it back in the engine and look at it as a whole, which is more like the system testing. But if I just want to look at that unit, that would be more like the spark plug. And that's what we try to do. We have the ability now to capture everything from a main program. We have the ability to capture that automatically and then isolate that program. And what I mean by isolate is kind of remove the dependencies that it has on other systems like the DB2 or your input files, subprograms. So we're truly only testing that main program. And that's the true definition of really unit. And Mark had talked about code coverage. One thing that we're able to do now is be able to, run a program, run that test case, and if we want to maybe modify the input stub file, we can change and tweak some of that data and force that test case to run the program down a different path. And that truly is, like I say, unit testing, because we're targeting certain areas of that code. And code coverage can teach us that too, is we can see first time I ran that test case, maybe I didn't cover that area. I tweaked the data just a little bit within my stub file, run it again. Now I can see that it hit that area of the code. So that truly is unit testing. If I want to put that spark plug back into the engine and run it as a whole, now we're talking more system testing. We're looking at the whole thing as a whole, but that's the difference between a unit and a system.
Kevin, the e-book discusses blending system and unit testing. How would an organization do that, and why is it so important?
Well, I think Paul may have hit on it just a little bit and talking about the differences between the two. But what's important is, in his automotive example, analogy of pulling the spark plug and testing it and then putting it back in, assuming that test passed, you can then automatically start the engine. Yes. To run automated testing on the rest of the system test, integration, whatever you want to call it, which is, from our products, you can do that. If something passes, conditionally, you can say, okay, now kick off this automated testing. So that's kind of what it is, but to blend them. And again, we've got products that are integrated that will allow you to do that. And it's very powerful. It's done to some extent at BMC as well from our development perspective. Once something has been unit tested and we're satisfied, it automatically kicks off a regression test, a system test, if you will. Not a full integration test, that comes later. But so that's really what it is, meant by blending them together. All automatic.
Mark, the 10 Steps to Effective Mainframe Testing e-book mentions the McCabe complexity metric, which identifies the number of unique test cases to cover the changes made. Can you go a little deeper into what the McCabe metric is and why it's important in ensuring test coverage?
Yeah, I would love to, because this is it's very important. And I think as you see, the theme of the book is that we understand the difficulties organizations have in testing and sometimes seems insurmountable. And what we're trying to do is offer practical solutions that can be easy to implement, that really offer answers. And I think the McCabe complexity metric is one of them. The challenge here is that you don't know how complex it is. If I ask developers, they'll probably proudly talk about how complex their code is. It's just whatever code you have to work on is going to be complex, right? It's what is the standard between them? What the McCabe complexity metric does is look at a paragraph within a COBOL program, and it figures out how many decision points there are, and then from there, how many unique test cases it would take to test that paragraph. So we like to have it be 10 or under. So let's say it's 7. If that paragraph has the complexity metric of 7, it means that if I tried to test with 5 test cases, I'm not going to test it, right? But I could throw 100, 1,000, 10,000 test cases. But if they weren't the right 7, I still couldn't test it. So I need at least 7, and there's 7 paths through there that would test it. Now, where that comes into testing, and I think it really applies to what Paul was talking about at unit testing, is if I really have my changes in this paragraph and a test of that, if the number is 7, I'll go, okay, I only need 7 test cases. It should be easy for me to get the right data, use code coverage, make sure I hit it. I can handle that. And if it gets into 15 or 20, I'm like, oh, that's going to be harder. But if it comes back, and I've seen this into 200, 800, or even more paths through that paragraph, that makes it very, very difficult to come up with all the test cases. And what I might then do is change my strategy and say, I won't do all the test cases. What I might do is to simple coverage, or I might go to branch coverage and adjust what I'm doing. It's also a candidate to refactor that code to make it easier to test. But if you can't do that right then, you have to adjust your testing strategy. And that's what it tells you. Just looking at the code, you may not be aware of it, but you could also really discuss the proper test strategy based on the true complexity, which is not just someone's opinion, it's based on that number. And we do provide the number. It's in the Topaz for program analysis. You can get that for any paragraph.
So, Paul, the book also mentions test-driven development. Can you explain that concept a little bit?
Yeah, test-driven development, it's a concept that's been around a long time, but basically, as a software developer, when you start looking at the requirements to write your application or program, you basically write the test case first, and then you start that code. So you're again kind of breaking those components down into the most smallest levels. So you might write your test case, then you write your code, and you test it, and then you go on to the next building block, and you would write your next test case, and then write the code behind that. So it's this iteration going on. And then after a while, you basically have the whole program written. But as you're developing the code, you're testing it. So you're, as opposed to, waiting to the very end, you code everything and then you start your testing. Test-driven development is that iteration back and forth between, writing the test case, then coding it, writing the test case and coding it. And, I know a lot of people do have success with that. Like I say, it's been around a while. So I know that when you start mixing in unit testing, that's kind of very similar to the unit testing process where you're breaking those components down to the very smallest measure and testing those. And, I think when we talk about using code coverage and how we optimize the data, when you're using test data development and unit testing, you're trying to get the data down to the very smallest level just to make sure that when you run that test case, it is truly matching the area of the code you're testing.
The book also has a section on continuous improvement, which is a central tenet of DevOps. Tony, if our listeners follow the 10 steps in the ebook, will they have a complete testing solution, or are these steps a continuous guideline? And I'd like everybody to jump in eventually on this.
It is a continuous guideline, man. You will never be done. It is a continuous rinse and repeat. Now, do you have to go all the way back to step one necessarily and go all the way back through every step? No. But each one of these steps at some point, you're going to reassess and you're going to see, am I still doing it? Am I keeping up with the latest standards? Am I keeping up with the latest practices and technologies? It's like getting in shape, man. Just because you got in shape and you're feeling good doesn't mean you can start eating whatever you want. You have to continue to build on that. You have to continue to stay in shape. It's the same thing here. You're never going to stop working on it.
Yeah, and I think that it is the continuous process, and you want to make sure that you're moving forward, that you don't slip back, that you have developers, not marking their code. So you have to make sure that, and not using code coverage, that these good practices, and while you get the benefits, you have to make sure that there isn't any slippage, or it could be accidental, just something isn't run. But make sure that these good processes, the good habits continue. And I think from the being able to have a test run in seconds instead of hours is its own reward, which will keep this going. Once these things are in place, people will want to use them because they're going to see the benefits. So I don't think you'll have too much trouble with that. But it's also a discipline and mindfulness to keep cutting back on your data. So you'll say, well, I have this and it seems to be good, but can I cut it back even more? Let me run code coverage on it. Let me cut it back to keep trying to do better, to test more often with smaller data. And there's always some work there. And then also, we put out new things every quarter to keep up with the things we're putting out, because this is really the way we see testing. We're doing things to enable sites to work with it. So keep up with us in our new features that will help you enable this.
Yeah, I was kind of going to say something along the same lines, Mark, that once you get to the end and you've got this, you've reached the goal that you set after step one. But once you've gone through that a little bit, as Mark mentioned, tooling changes. Our tooling, other companies' tools change. And we're all trying to make it easier for development teams to go faster and produce quality work. So I would really, suggest that once you've reached that desired state, that you go back to step one at some point. It doesn't have to be each and every single time or every day or every week, but look at it and say, okay, I know what state I'm in now because we defined it and we achieved it. What else can we do to make it better? And, Mark alluded to a couple of those things, but, to constantly reassess. That's what we do in this business, is we constantly reassess and make change so that we improve continuously.
Yeah, I think you make some good points, because, you hit on the fact that companies are trying to move fast, and inevitably with moving fast, you could introduce bugs and put out code to your customers that you don't want. So I think, adding more test cases, being able to test, like I say, with unit testing and catch bugs early and often before they get out to, your customers is ultimately what we're trying to accomplish here. So I think having all the concepts that we had talked about in the 10 steps, help companies get to that point where they have that more assurance that what they're delivering to the public and to their customers have that testing background. We're not regressing back to code that's bad. So I think we're adding some assurance that when we do deliver code, it has been thoroughly tested. Maybe not always 100%, but we strive for those higher numbers, especially with code coverage, and we have now the metrics that can determine what coverage we do have. So I think it's you're buying into like this, like I say, assurance that we're delivering a quality product.
Yeah,
and let's emphasize that what we're talking about as far as testing. I know we've said it many times, but it's automated. It's almost a must that it has to be automated in order for you to go fast. And if it's automated, you're ensuring quality.
And it's going to happen. You don't have to second guess it. Did someone skip it? You can't skip it. It's automated.
And it's consistent. So you're getting the same test every time. It's not human error or did the guy read the spreadsheet wrong. It's a consistent test of that feature, that function, that capability, that whatever, each and every time.
And, going back to like step one is picture your future state. And you sort of, your future state probably continues to move, right? You accomplish everything and then you have some new goals and you keep going to new goals. So there's that aspect. But along the way, the positive thing is what you're doing for the developer experience. By automating these things, you're taking testing, which is a drudgery and which is they're not sure, and that so they throw more data at it as just a test, and you don't really know if it's effective. And so, and bugs get out in production. To take it from that world to where change code all gets tested before it goes out. You reduce your bug count. Testing can be done automatically, so you don't have to do it. No one's asking whether it's been tested or not, or how well did you test, because it's all there. The developers will really value from this, and they can concentrate on providing for better applications and thinking about that and providing better code rather than getting caught in fixing bugs and spending their time testing or thinking about it. Having these things in place makes such a great environment. So that's an important part of setting the goals in the beginning. And once you get the goals, you don't say, oh, we're done. It's continuous improvement in step 10 to set new goals. And I think the developers will be totally on board with this because they'll see how much better their developer experience is.
And we talked about organizations not understanding how all of their code works or interacts and what kind of data it uses. As you move along with this automated testing,
you have that confidence.
Right. You have less work to do by starting out not really knowing what the code is, where the data is coming from. With the automated testing, in the future, you don't have to go back and figure that out, right? You kind of, if you go through these steps, you've got that worked out for existing code, and you also have it worked out ready for new code.
Right. It's confidence. It's, I got this.
It's not only confidence, but it's you learned something. You've gained knowledge about how this application works.
All right.
Let's say it a different way, though, Matt. What you have is a framework. You have a framework. So not only do you have your existing code covered, but as you make changes and as you maximize the platform, as you modernize your applications, as you make the mainframe just another platform in your data center, then now you have a framework to be able to automatically test all those changes that you're going to do. As you start breaking your systems down into microservices and into smaller components, so you can start bringing some of the cloud goodness onto the mainframe platform. You have a framework by which you can actually test all of these changes and basically enhance your development environment. It goes back to making things a delight. It makes it easier to work with, easier to work for.
One final question, and I'll start with Tony, but anybody who'd like to chime in, please do. As organizations look to make their mainframe application testing more effective and efficient, what features should they look for in testing solutions?
That's a great question. That's a really good question. I think that they should look, I think the key thing that we just talked about was automation. The ability to hook this into any pipeline, any process, and automatically trigger those tests. I think integrations and capabilities that span unit testing, functional testing, regression testing, stress testing. You want to look for something that does maybe not a Swiss Army knife that does one thing in all, but a solution set that gives you all those capabilities and how all those capabilities tie together into a single pipeline. I think as you're looking across, you need to see a tool that gives you those capabilities to be able to automate whatever. Maybe that's a little too eclectic, but I'd love to hear everybody else's opinion on it.
Yeah, it's right. If it's a manual solution, that's good, but we know the difficulties in always remembering to do it and doing it. So you want to look for tools that can be automated, and you also want to make sure that they're very open, which means, webhooks, APIs can fit into a pipeline. So if they're open, they're more likely to be automated, which means they'll be used and relieve that burden on the developer.
Yeah,
I think that one of the things we're trying to get at is that we've said throughout this podcast is that the tooling really needs to be integrated. If you have standalone pieces, then you have to somehow join them together, marry them together, whatever, in some kind of a process that will work. But a lot of the things that we've talked about today are fully integrated, one product to another. The spark plug and automatically starting the test after the spark plug passed is an analogy of that, where we have, not an analogy of that, is an example of that, where we have total tests that has integration with enterprise data, and it just all flows together seamlessly. So I think that's an important aspect of what kind of tooling you should be looking for to improve your DevOps experiences.
Yeah, and I was going to piggyback off what you were saying, is that we do have a lot of the tools that do have that integration, and then, they all kind of work together like gears. So, man, I'm talking about cars the whole time today. But,
hey, we're from Detroit.
Detroit.
Yeah. But yeah, I mean, we've put thought into how these tools all integrate together. And that, when you're buying into that DevOps story, you want to make sure that, you look at the whole process, not just one part of the process, which is maybe, like a total test, which is just the testing part of it. But we have, ISPW and other tools, but we all have this integration across the board. So, when we buy into the automation process, we want to make sure that these all fit together.
I think the biggest thing, and I think we would all agree, is integrations. It has to tie into everything else. It has to seamlessly tie into your process and be something that you can easily decouple and couple in something new as you need it.
Right. So it's something like I think I mentioned earlier, is you want it so that every time I do a compile, it could kick off a test. Or every time I do a promotion of code, it could kick off a test or different tests. And right before I go and do like a deploy, it could go and do it. You want it tied in. You want pipelines tied into pipelines so that things automatically trigger these tests and that they have gates on them so that if it fails, like, wait a minute, you've got one of your change pieces of code wasn't tested, it stops you right there at an early process. It's that enforcing the shift left testing that really pays off.
Well, we've covered a lot of ground, and there's more that could have been covered. We also got a great look into the 10 Steps to Effective Mainframe Testing e-book. But Mark, Kevin, Paul, Tony, thanks for joining us. And it's a great book. I'll put a link in the show notes for people to download it and read it for themselves and hopefully start along this road of automated testing. So
Absolutely.
Thanks for joining us.
Thank you, man.
It's been a pleasure.
And thanks to everyone listening. We'll talk to you next time on The Modern Mainframe. Take care. You're listening to The Modern Mainframe, BMC's intelligent Z optimization and transformation podcast, covering the latest trends and issues on the mainframe and how BMC AIME and BMC Compuware Solutions can help you build a mainframe-inclusive DevOps toolchain.